Hello everyone, welcome to lecture number 4. In this lecture we will be deriving the Hazen-Poiseuille formula, which is very important formula in this chapter. Okay, let us first understand what Hazen formula gives us. It gives us the drop of pressure. For a given length, say for a given length L. Okay, so let us see what does it mean. Okay, so this is our circular pipe which we have considered, and let us consider two sections. Okay, let us consider two sections, section 1 and section 2. Let us name it as section 1 and section 2. Okay, so in these two sections we know pressure forces will be acting. Say P1 pressure intensity is acting on section 1 and P2 pressure intensity is acting on section number 2, and let the distance between the two sections be L. So what we will find in Hazen-Poiseuille's formula is that the change in pressure or the drop of pressure for a given length of L, we need to calculate del P. From del P we will calculate the loss of head, right? What will be the loss of head? H of F is denoted by loss of head. We know loss of head or head is the ratio of pressure upon its unit weight. Okay, so what will be the loss of head? That will be change in or loss of pressure divided by the unit weight. This density will be the density of, say, water for our example, and G is the acceleration due to gravity. Okay, so let us see how we will derive the Hazen-Poiseuille's formula. Okay, so from the previous derivation, we calculated what? Average velocity equation, right? Average velocity, which we denoted by U bar, was equal to what? Minus 1 by 8 mu del P by del X into R square, right? This you can find the playlist for this in the above mentioned information bar. Okay, so do check out the video before going through this video. Okay, so U bar will be equals to what? Minus 1 by 8 of mu del P by del X into R square. Now see, let us bring del P by del X to one side. Okay, so what will be on the right hand side? 8 mu U bar divided by R square. Okay, let us bring this delta X to this side. LP will be equals to what? 8 mu U bar R square into delta X. So now we will integrate both sides. And from the diagram we know the limits. What will be the limits? We consider two sections, say 1 and 2. Okay, P1 pressure was acting on this section and P2 pressure was acting in this section, and the distance between them was L. So P1 will change from where? P1 will change from P1 to P2, and delta X or the distance is changing from, let us consider this to be the datum, so this will be 0, and what will be the other section? It will be at the length of L. So 0 to L. Okay, now let us integrate. What will be the integration of del P? It will be minus P. What are the limits? P1 to P2 equals to del mu U bar upon R square is a constant. Integration of del X is X. What are the limits? 0 to L. So now let us rearrange. P2 minus plus P1 equals to 8 mu U bar L upon R square. Okay, so P1 minus P2 will be equals to what? 8 mu U bar L upon R square. Now let us put the diameter instead of the radius. U bar L upon D by 2 whole square. So what is this? Will be the change in pressure, right? P2 minus P1. Let us denote it by del P. T square and 2 square into 8. What will be the answer? 32 mu U bar L upon D square. So this is the drop of pressure. This is the drop of pressure for a given length of how much? Given length L is the given length. Okay. So now let us see the loss of pressure head. What will be the loss of pressure head? Therefore, loss of pressure head. We had earlier established what is the loss of pressure head. It is the change in pressure divided by the unit weight of water. Change in pressure we have calculated 32 mu U bar L upon D square into rho G. So this is nothing but the Hazen-Poiseuille's formula. Hazen-Poiseuille formula. Very important formula. Very important formula. It has been asked many times in your exams, right? You are to derive this formula, and based on it many derivation will also come, and numerical will be a must in your question papers. Okay. Now see, this question has come in your ASTU 2019 repeaters question paper. Okay. See the marks, 12 marks, and we are to derive starting from the momentum equation. That is why the marks is 12. Hazen-Poiseuille's formula we have to derive starting from the momentum. Now what does it mean? That means we have to start off from the shear stress. Okay. Again from there we have to calculate the velocity distribution. From there we will calculate the average velocity, and using the average velocity equation we will derive the Hazen-Poiseuille formula. This will give you the total 12 marks. Okay. Now if the question is asked for say 5 marks, that you have to derive the Hazen-Poiseuille's formula, then you can directly use the average velocity equation that you know and directly derive for 5 marks. Try to understand the difference. If it comes for 5 marks, you can directly use the average velocity equation that is shown in lecture number 4. If the total comes for say 12 marks, then you have to go for the entire process. Okay. Now shear stress derivation is shown to you in lecture number 1, velocity distribution in lecture number 2, average velocity in lecture number 3. So all this has been covered. Go through it properly, and I hope this question is clear to you. This is very important. Do mind it. Now let us try a numerical based on the Hazen-Poiseuille's formula, which has come in your ASTU paper. Okay. This question has come in your 2019 repeaters same paper. See, from the Hazen-Poiseuille's itself 12 plus 10, that is your 22 marks has come in the same paper. Okay. You can check out this question paper. I will give you this question paper in the link below. So please check out the entire question paper. Okay. So let us now see what are the given things in this question. Crude oil of density mu equals to, let us write down the given things. Okay. Mu is given to you. Dynamic viscosity, how much? 1.5 poise. Let us convert it to SI. What will be it? 0.15 Newton second per meter square. Okay. Next, the relative density. Relative density is given. That is 0.9, or you can say the specific gravity is given to you. From specific gravity, how we will calculate the density of the liquid? We will multiply it with the density of water, that is 1000 kg per meter cube. So what will be the density of liquid? It will be 900 kg per meter cube. Okay. Next, the pressure gauges fixed at two different points 20 meter apart read 58.86 Newton per centimeter at the lower point, 19.62 Newton per centimeter square at the upper point. Okay. Pressure gauges are fixed. Pressure gauges are what? These are pressure measuring instruments. Pressure gauges are pressure measuring instrument. So let us draw a pipe first. So this is our pipe. Okay. This is our pipe. Let this be the center line of the pipe. And what is it saying? The duta gauge fix korise two different points of 20 meter apart. Say first gauge to more yat ase and next gauge to more yat ase. ठीक আছে? Gaugeor center line dal মই এনেকে draw কৰি লৈছো. কিমান distance apart কৈছে 20 meter apart আছে. ঠিক আছে? Vertical pipe কৈছে সেই কাৰণে vertically আকিছো মই. ঠিক আছে? Horizontal pipe নহয়. And they are at a distance of 20 meter apart. Lower point of pressure intensity kiman koise? Let me name them. Let me name this as A and let me name this as B. A lower point dhorisu moi. Lower point at kiman dia ase pressure intensity? Pressure intensity at A is 58.86 Newton per centimeter square. Meter square le loi jua 58.86 into 10 to the power 4 unit ki hobo Newton per meter square. Soboke ami SI unit le loi jam. And next to pressure intensity kiman dia ase? B mane upper point boli koise. Upper point tot kiman dia ase? 19.62 Newton per centimeter square. Aku SI unit le loi jam. 2 into 10 to the power 4 Newton per meter square. So ulabole ki dise? Find the direction and rate of flow. That means say direction A to B flow hobo ne B to A flow hobo. And what is the rate of flow mane Q ulabo dise. ठीक है. This is what we are required to find. Now let us see one by one. First let us see what is the direction of flow. Okay. First ami some direction of flow. Direction of flow. Direction of flow kenake ulam? We know water will flow from a region of high energy to a region of low energy. ठीक है. We know this, so we have to calculate what? We have to calculate the total energy at the 2 points, that is at A and B. And আমি জানো total energy formula কি হয়? P by rho G plus V square by 2G plus Z. P by rho G is your pressure head. This is velocity head. And this is your datum head. Right? এখিনি আমি already পাইছো. কোৰপৰা পাইছো? From Bernoulli's equation. Right? So we will calculate the total energy at the 2 points. And sum ki core energy besi. Jot energy besi, suppose total energy at A is greater than total energy at B. So we will know the flow will occur from A to B, or if vice versa. Now let us again draw the vertical pipe. This is my pipe. These are the pressure gauges. Yarata gauges ile. Yarata gauges. ठीक है. Yeah, P A asile. This was my A point. This is my B point. The distance kiman dura asile? 20 meter distance dur dia asile. ठीक है. PA PB amak dia ase. PA PB bole denote koisu. Value to I have already written. Okay. So since the rate of flow is same, ठीक है. तार माने QA will be equals to QB. Same method ulaba because its diameter is also same. Also, diameter of the 2 points is what? Same. That means we know what velocity is equals to Q upon A. Since QA both cases is same and area of cross section will be same for both the sections since the diameter is same. The velocity head, which is v square by 2g, will be same for both the cases. So that means total energy jagat we will only calculate the piezometric head. Piezometric head mane ki only the pressure head and datum head, because velocity head for both the points A and B will be what? Will be same. So we will not be calculating the velocity head. So let us calculate the piezometric head at A first. Piezometric head at A. P होगा what? Pressure intensity at A divided by rho G plus Z of A. Now pressure intensity at A किमान दिया आसिले? A point of किमान दिया आसिले? 58.86 into 10 raised to the power 4. Density किमान आसिले? 900 and G किमान 9.81 plus the Z किमान होगा? Let us consider this point. Let us consider considering point A as datum. Datum mane ki? Let us consider point A as datum. That means jiman measurement koren we will take this to be our 0 0. Okay, this is our baseline. Eto amar baseline hisabe loi lolo point A. So here datum head kiman hoy jabo? Kiman hoy jabo koa? Datum head hoy jabo 0. So we are getting a value of 66.67. What will be the unit? Unit will be meter. Clear? Since we have considered the datum at A, so ZA will be equals to what? 0. So now let us calculate the piezometric head at B. किमान होगा P of B by rho G plus Z of B. P of B किमान होय 19.62 into 10 raised to the power 4 divided by density is again 900 into 9.81 G plus what will be the value of ZB. Now see, A to the datum, B point to kiman durot ase. This is the distance of B point. ZB will be equals to what? 20 meter. ठीक है सर, यार पूरा distance में से कोई को लेके जाबो लिखबो B point लेके. So ZB हो जाबो 20. So finally हमें किमान पालो value तो value comes out to be 42.22 meter. Now since piezometric head at A is greater than piezometric head at B, therefore flow flow will take place from A to B. I hope this is clear. Now next part of the question is to calculate the rate of flow. For rate of flow, I know what I have to rate of flow करना Q equals to A into U. A U to की है average velocity है ना? Sorry, average velocity है ना? A to मैं जाने cross sectional area. Average velocity में कहने के होगा मित्य from Hazen-Poiseuille formula. Yes, Hazen-Poiseuille's formula. Sorry, F is equals to 32 mu U bar L upon rho G D square. Now see, की जानो हमें head loss जानो हमें किमान head loss होसे head loss माने difference in piezometric head heads किमान head loss होसे ले पानी 60 6.67 minus 42.22. Calculate this value. What will be the value? To be 24.45 unit will be meter. Now so HF equals to P 32 mu u bar L upon rho G D square. Available put को बता रहा है 24.45 equals to 32 into mu की माना सिला मोर mu सिला 0.15 into u bar में लगे L की मान L will be the distance between the 2 points, that is 20 meter. Rho is 900 into 9.81 into d square. माने diameter of the pipe की मान दिया सिला मोर 20 mm दिया सिला तर माने 0.02 whole square. So just calculate the value of u bar. It will come out to be 0.9 meter per second. Therefore, discharge will be what? 5 by 4 into 0.02 whole square into 0.9. So the answer comes out to be 2.827 into 10 raised to the power 3 meter cube per second. So this is your answer. Okay. So I hope you have understood the numerical. So thanks a lot for watching our video. I hope you are enjoying our videos. If there are any suggestions, you can write it in the comment section. For more videos on hydraulics and hydraulic machines, you can check out the playlist. Also, for other subjects like concrete technology, you can also check out the playlist which I have mentioned in the right hand side thumbnail. Thank you. So keep watching.